very good day to our lecturer. Today we'll be doing a lab video presentation for the experiment rate of reaction. Our group comprises of 5 members, namely Noor Auni Awada, Muhammad Dimal, Jiu Kahing, Watson Jin, and Tengku Fatin Noor Diana. The abstract of this experiment can be summarized in a few points. This experiment revolves around the fundamental rate of reaction between chemical reactions. The rate of reaction can be described as an increase in concentration of product over time or a decrease in reactant over time. The method used for this experiment is a simple chemical reaction tested in a beaker on top of a paper marked with X. The result of this experiment includes the least time taken for the X mark to disappear is 43 seconds when 1.0 molarity sodium thiosulfate reacts with 10 mm 0.1 hydrochloric acid. And lastly, the least time taken for a solution to become colorless is 5 seconds when the temperature is 50 degrees Celsius and manganese sulfate catalyst is added.
Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Tengku Fatin Nordana binti Tengku Nur Azhar. My ID number is TH21069 and my part is methodology flow chart. Okay, for part A is determination of the effect of concentration on the rate of reaction. Start with in a conical flask, add 50 ml of 0.1 m sodium thiosulfate. Put the conical flask on a piece of white paper on which a cross has been drawn. Add 10 ml of hydrochloric into a conical flask and start the stopwatch. Stir continuously with a glass rod until the cross on the white paper is not visible. Note the time required for the cross to disappear. Okay, repeat step 1 until step 3 with addition of distilled water to the solutions. To the sodium thiosulfate as instructed in table 1. This is table 1. Table 1 that given volumes of solution, volume of distilled water, volume of hydrochloric solution, and concentration and time course. Okay, for part B, determination of the effect of temperature and catalyst of the rate of reaction. Start with place 10 ml of 0.25 oxalic acid solution in two test tube labeled as A1 and A2. Test tube B1 with 5 ml of potassium permanganate solution and 10 ml of sulfuric acid solution and stir with a glass rod. Okay, for fill test tube B2 with the same solution in test tube B1, but we add 5 drop of 10% magnesium sulfate solution. Place boiling tube A1, B1, A2 and B2 in hot water with preset temperature table 2. Okay, mix the solution in test tube A1 and B1. Note the time taken for the mixture to become colorless. And then for this, mix the solution in test tube A2 and B2, and then took the time taken for the mixture become colorless. And then repeat step 1 until step 5 for the each temperature as in table 2. This is diagram for table 2 and given it has a given temperature and then time taken solution become colorless. This is 30 degree, 40 degree and 50 degree. And then that's all for me. Okay, thank you.
Hi, my name is Shuka Heng and my ID number is TH21051. And I would like to proceed the presentation with the result obtained in this experiment. The result can be divided into two parts, which is the part 1 is the concentration of the reactant, and the second part will be the catalyst and also the temperature to affect the rate of reactions. So for the first part, we use three different types of solutions, which the first one is the sodium thiosulfate and the 2S2O3, and also the second one will be water, and the third one is HCl. HCl will be added into the solutions of sodium thiosulfide and also water at constant rate, which is 10 milliliter, while the difference will be the sodium thiosulfate and also the distilled water. So our main aim is to observe how many seconds that it will take to let the cross that has been put under the conical flask to be disappear completely. As we observe, the higher the concentration of water, then it will take longer time for the cross to be decreased. This is shown by the data proof, which 50 ml of the sodium thiosulfide and 0 ml of the water will take about 30 seconds for the cross to be disappear, while when there are 10 ml of sodium thiosulfide and 40 ml of water, it will take longer time, which is 540 seconds for the cross to disappear. Hence, it can be concluded that the concentration of water increase, the time of cross to disappear become longer. So for the next presentations, will be the effect of temperature and catalyst on the reactions. So the effect and also the catalyst are proved to have effect on the rate of reaction, because based on the data taken, where we put the catalyst as MnSO4 and also with the another solution without the catalyst, it shows that the solution with the catalyst take fastest time for the solution to become colorless. Hence, this has already shown that the theory of catalyst increase the rate of reaction. And the second one will be the temperature. So with or without catalyst, the rate of reaction also has been shown to be increased. For the catalyst solution, the solution takes around for 30 degrees C, it will take around 0.08 seconds square to become colorless. However, if the temperature is increased to 50 degrees Celsius, it will take 0.033, which is the shorter time to decrease to become colorless. For the second will be the with catalyst. So with catalyst and also higher temperature, it will take fastest time for the solution to become colorless, as the result shown that 0.20 seconds square of the solution second have been completely become colorless when the temperature is at 50 and also catalyst. Hence, this is because the increase of temperature causes the collision of particles, hence increase the rate of reaction. And that's all for my presentation. I would like to invite Dima to discuss more further detail about on discussions. Thank you.
For the discussion part, the concentration of sodium thiosulfate obtained is 0.1 mole, 0.08 mole, 0.06 mole, 0.04 mole, and 0.02 mole. For the value of 1 over time obtained is 0.033 second, 0.022 second, 0.011 second, 0.008 second, and 0.001 second, respectively, to the concentration of sodium thiosulfate. So, for the graph obtained is the relation involved is the concentration of sodium thiosulfate increase linearly with the value of 1 over time. For the part B, the rate of solution to become colorless. For the without catalyst manganese sulfate at temperature of 30 degree, the rate of 1 over time is 0.008, and for which catalyst manganese sulfate, for the temperature 30 degrees Celsius, it is 0.055 second. For the temperature 40 degree, without catalyst manganese sulfate, the rate is 0.013 second, and with catalyst, it is 0.083 second. For the temperature 50 degree, the rate is 0.033 second, and with catalyst, it is 0.2 second. Moving on, by looking at the graph, we obtain that as temperature increase, the value of rate of reaction also increase, and the rate of reaction increase with the presence of catalyst. For the equation that involved in part A, it is sodium thiosulfate plus with hydrochloric acid, it will give sodium chloride, water, sulfur dioxide, and also sulfur in solid form. For part B, potassium manganate is added with oxalic acid and sulfuric acid. It will give manganese sulfate, potassium sulfate, carbon dioxide, and water. For the function of catalyst used in part B, it is used to increase the rate of reaction of the mixture by lowering the activation energy. And conclusion from the graph that have been plotted, for the graph on part A, the concentration of sodium thiosulfate increase linearly with the value of 1 over time. And for the graph on part B, as temperature increase, the value of rate of reaction also increase, and rate of reaction increase with the presence of catalyst.
Assalamualaikum warahmatullahi wabarakatuh. I am Dr. Hajar with the result TH1045. Present the conclusion. In conclusion, the rate of chemical reaction is influenced by a variety of factors. Because different compounds have varying activation energies, the nature of the reactant has an impact on the reaction rate. The rate of reaction can be affected by the frequency of collision between reacting molecules, which is affected by the concentration of reactants. The frequency of reactant collisions is influenced by temperature, as is the energy of those collisions, the amount of available or exposed sites to react on is influenced by the surface area of responses. Finally, the presence and nature of catalyst affect not just the reaction activation energy, but also the mechanism by which the reactant reacts. The higher the concentration of solution, the faster the sodium thiosulfate dissolve. Chemical reaction increase. The lower the concentration of solution is, the slower the sodium thiosulfate dissolve. Chemical reaction rate decrease. Concentration affect the rate of chemical reaction. The higher of concentration of the reactant is, the higher the rate of chemical reaction will be. The lower of concentration of the reactant is,